Hey, this is our E102 Milestone project. I am Ezra Proffit, and here are my coworkers.
My name is Luke Jenquin.
I'm Matthew Sedor.
And I'm Teddy Dano.
Now let's get started.
The ability to hear oncoming emergency sirens may seem like a normal and unimportant to most people, but to those who are deaf and hard of hearing, it is a major hindrance to their situational awareness while driving. The vibrational alarm system for public emergency vehicles, VASPEV, would solve this problem for those with hearing disabilities by utilizing a system that can be implemented into any type of vehicle. The VASPEV would then be paired with the emergency vehicle locator to identify when any active emergency vehicles are within a certain range, and then proceed to release a warning to the driver through vibration of the steering wheel. These vibrations will vary in intensity depending on how close an emergency vehicle is to the vehicle installed with the VASPEV.
Drivers suffering from serious hearing loss are incapable of hearing approaching emergency vehicles. According to the National Library of Medicine, approximately 1 in 20 Americans are currently deaf or hard of hearing, and nearly 1 million Americans are functionally deaf. Because this large population primarily relies on optical and tactile feedback to be aware of their surroundings, they are unable to anticipate approaching emergency vehicles that are beyond the driver's line of sight. With a VASPEV solution, drivers that are hard of hearing and deaf will be aware of these vehicles and can alter their driving to preemptively avoid confusion and collisions. The VASPEV is designed to help people who are deaf and hard of hearing know when there are emergency vehicles that are within a certain area of them. It will notify the driver of the vehicle through the vibration of the steering wheel. These vibrations will vary in intensity based on the location of the emergency vehicle relative to that of the vehicle with the VASPEV installed. This should then allow drivers with hearing complications to have more situational awareness while driving, which will ultimately provide more safety to them and emergency vehicle operators rushing towards situations where they are needed.
Okay, so the relation to the engineering grand challenges. The two primary grand challenges that our solution is closest to is engineering better medicines and advancing health informatics. For engineering better medicines, we are using technology to make up for hearing loss. Technology is used as a solution and treatment option where it's essentially a substitute for actual medicine. For advanced health informatics, by using VASPEV, we are going to be able to gather even more data about how hearing loss can affect driving. More data will allow us to learn even more about deafness and potential ways to alleviate its impacts. So, using existing technology, VASPEV could or would be paired with a device similar to the emergency vehicle locator, which is patented. The associated device detects emergency vehicles within the general proximity of the driver's car, and VASPEV will alert the deaf drivers through a vibrational warning, in which the intensity and the duration of said vibration will depend on the proximity of the emergency vehicle.
The duration of vibrational alerts will continue as long as the emergency vehicle is within a radius of 100 meters of the driver. The intensity of vibrational alerts will increase every 20 meters as the emergency vehicle approaches the driver, and vice versa as it passes the driver. The lowest intensity will be just noticeable enough for the driver, and the highest intensity will be equivalent to a rumble strip. Here you can see 5 concentric circles, the largest with a radius of 100 meters. As you can see, the color changes to increase with warning as the driver is starting to sense a higher vibration in their steering wheel. From blue to green is not very noticeable, but from orange to red, it starts to become very noticeable, almost as that of a rumble strip. The driver should then know that their situational awareness is dangerous and they need to pull off to the side or be cautious. Thank you for watching our presentation.